Now in the previous video, what we have learned multiplexer circuits. What it actually does, it actually combines all the inputs into a single output. Now there must be some device which actually does the opposite thing of the multiplexer. That is, it actually takes one input as input data source and gives several outputs, or n outputs for that matter. Here in this video, we will be learning such things. So, hello and welcome to Easy Classroom. For today, we will be learning Demultiplexer circuit. Now, what is demultiplexer? It is just the opposite of what we have learned in multiplexer, as we have already known by now. That is, demultiplexer actually does the opposite thing, as it takes one input and gives n number of outputs. So here are the few key points that we need to consider in order to get the demultiplexer circuit right. So as we all know, demultiplexer is also a combinational circuit which actually takes one single data input, and with the help of special inputs, that is select inputs, it will direct that data input towards the n output channels. So here is the block diagram of demultiplexer. As we have seen, demultiplexer is also written as Demux, and in multiplexer what we have done like this: n is to 1. In opposite, demultiplexer will take 1 is to n. So it is just the opposite of multiplexer. So here is the input signal. It will be one single input and it will be directed to n number of output channels with the help of this n number of select inputs. So how many select lines and how many outputs will be there? So this is the same as that of our multiplexer, but a little bit different, as here n is the output, not the input signals. So if n is 2, so actually what we are looking for is the 2 signal output. So the same thing goes for here also. N equals 2 means this 2 can be represented as 2 to the power 1 equals 2 to the power n. So number of n's will be 1. So the select inputs will be 1 in this case. So here is the 1 is to 2 Demux, where what we have done this signal, that is input. We can write this as input, data input, for example. Here also data input. And there is a select E, where E is 0, the circuit will not work. When E is 1, circuit will definitely work and give the necessary output. Now, and it will produce these 2 output columns. Okay. So now what are the things where these can be used? It can act as data distributor, as we have already seen in multiplexer. It is actually combining all data. So it combines. Here it doesn't combine, it distributes. So it can be act as data distributor. It is used in the same as the multiplexer in the communication system, in serial to parallel and in ALUs. Okay. So what are the types? Same as multiplexer, it can be used as this: 1 is to 2, 1 is to 4, 1 is to 8, 1 is to 16, 32, and so on. So what we can do, we can create the circuit and let us understand how it happens. Then we can clearly understand what actually happens over the truth table. Okay. What we need to consider here, we need to consider what are the output signals and where we can put this output. Okay. So input is 1, and if we need to actually divide this output into 2 or more, we need certain kind of logic to deliver these things, and this logic is controlled by this S or selection input. So let us consider for the circuit only. For 1 is to 2 Demux. For 1 is to 2 Demux. So here is E I S and then there are two lines. So let us now consider this circuit is 1 cross 2 Demux. We are to select which of the outputs will go for this input. Okay. So the input is all connected to both of the circuit with E, and since the S will be our selection input, the S0 or S bar is here connected with this, and S is connected with this. So when S is 0, say for example the S is 0, okay. So for this circuit, what will happen? So we have E, I and S. So here it will be E, I, S bar. So now E is 1, I is I, and S is 0. So S bar will be 1. So the output would be I. So for this Y0, the output will be I. For at the same point of time, what will happen on this circuit as Y1? So what will happen? So since S is connected over here and S is 0, so whatever we are ANDing with this S or 0 will be 0. So Y1 will be 0. So for S equal to 0, Y0 will be selected as output. For now, let us consider for S equals 1. What will happen? So now the S equals 1. So what will happen? So S equals to 1, since this is connected with S bar, so it will not be 1 but will be 0. So the output will be 0. So for now, this Y0 is 0, and at the same point of time, what happens here? Here S is 1. So output is I. At the same point of time, when S equals 1, Y0 will not be selected, Y1 will be selected. So here the output is I. So this is the actual logic how demultiplexer works. So when S is 0, Y0 will be on, S is 1, Y1 will be on, or Y1 will get the output. Let us consider this circuit. Now since we have understood for S equals to 0, what will be the output? Y0 will get the output. So S is 0, Y0 will be the output, that is I will be considered, I will be directed towards Y0. So here the I's value is here, and the rest of these two, for these two outputs, the I value should be 0. So here it will be 0 or negligible, and for s equals 1, what will happen? I will be also be selected, and for now here it will be, so here this will to be 0 and here for 0 and 1. So now what will come out of this circuit? What equation do we have? So what we have for I0, for Y0, what we have? We have this. So this entire thing will be selected. So E dot S bar dot I, and for Y1 we have this E dot S dot 1. This is how our demultiplexer works, and this is how our select inputs actually selects which of the output to give out. For 1:2 demux, these two are the outputs, and this is how for any 1:4, 1:8, 1:16, this logic will be performed, and these will be the operational procedures. So if you have learned anything new from this video, please do like, share and subscribe, and please do watch the full video. Thank you for watching.